Okay, so just show of hands, everybody, if I say decapping, do you know what I'm talking about? That's a perfect conference. All right, so I won't be explaining any of that. What I will be doing is breaking this talk into 3 parts. So we're going to talk about making nitric acid. So the process that's involved in it, that's the process I'm going to use to decap chips. There's a lot of processes that are out there. I'll kind of explain why later, why this is the one that I chose. And I'll talk a bit more in this talk about a lot of the things you won't find on YouTube when you try to watch videos on how to make nitric acid, which is like how to store it, which turns out to be incredibly challenging. Then I'll talk about decapping the chip. So once we have the nitric acid, how do you actually decap a chip? And there's kind of like a few things, like you see the one in the middle there in the video is kind of what I call like the spray and pray method. You just put some acid on it and you hope it goes where you want to go. And then I've worked on trying to refine it a bit to the picture in the top right that's a little more controlled. And then in the one in the bottom right, which looks like I milled it or did something else to cut into it with a laser, but that's just 100% acid that was controlled where it goes. And then after we've decapped it, usually you want to image it. You want to look at it in some way. You want to compare it to see if it's counterfeit to something else. You want to see if there's a ROM, like the talk we heard earlier. Is there a ROM inside the chip or not? It's like if you can decap it, you can take a look in 5 minutes and see if there's a ROM inside the chip. And so who am I? As he said, I've done a lot of YouTube videos on reverse engineering smart meters and things that are on the power grid. I created a news show that's called Reverse Engineering News, where I try to feature work that people like yourself post and put out there to kind of just raise awareness for everybody in the community of what people are working on. And I have a website and a wiki where I encourage people to post projects that they're working on, share it with everybody else, and just take things apart, encourage people to take things apart. When I was a kid, if you had a screwdriver, you basically knew how something worked. Like if you took it apart, everything was there. Analog circuits, digital logic. You didn't need anything else other than the schematic, which you could create yourself. Now everything's a blob inside of a chip somewhere. And so, I'm trying to morph the screwdriver for people. So the first step is we need the acid. So let's talk a tiny bit about safety. Not a lot about safety. I didn't cover it too much in one of my videos, but I think it's dangerous, and I think you should still do it. A lot of things in life are dangerous, and you do them all the time. So why not this thing, right? Everybody says, don't try this at home. I think you should absolutely try this at home. So I say plan for disaster, because if you plan for the disaster, then generally you'll have a very uneventful kind of thing as you do it. And so what could go wrong? It's like there's going to be fumes. You're doing a chemical process. You don't need a fume hood. This is not a fume hood. If you take a look, I'm in my garage. That's a box fan that's sitting on the table. All you need to do is pull the fumes away from you. That's all a fume hood is doing. If you've been looked at a fume hood, they're not violently sucking fumes away from you. It's just kind of rising in the right direction, right? This does the same thing, but even stronger. You want to be on a surface that when you spill, because you're absolutely going to spill stuff, drops here and there or whatever, that surface doesn't react in some way that you're not expecting it to react. You don't destroy it or whatever else. This is cement backer board. It's used in home remodeling projects. You put it up in your bathroom before you put tile up, which we're doing in my house. But if you spill acid on this, absolutely nothing happens. Like you can pour nitric acid on it, fuming nitric, concentrated sulfuric, anything you want. It does nothing. And when you're done with it, you just neutralize it. You put it in a trash can or responsibly dispose of it, whatever you have to do. And then, with the fumes and everything, you're just going to suck them literally to the outdoors. And there you go. There's not a lot of fumes. You just don't want them building up where you are, and you don't want them going towards your face. Now, ideally, you don't want to lose your hands as part of this process or disfigure them in some way. So gloves are good. There's a lot of different kinds of gloves you can use. I bought these Viton gloves. They're really good for nitric acid and sulfuric and other things. But gloves aren't like, there's not one glove to rule them all. Like if you put acetone on these gloves, it will start to eat them up. If you have nitrile gloves and you put those on, they will just get really hot and burst into flames. So you want to make sure that what glove you're putting on. It's not a guessing game with the gloves. And then your face, that's also important. You'd like to keep that the way it is. Face mask is only $20. Just get the face mask, put it on. As you can see from the video where I start this, where it looks out, it doesn't block your view. Like once you put that thing on, you completely forget that it's there. It's good to have it on. I hang mine kind of on my fan so I don't forget. And some baking soda. Like you want to be able to neutralize should a spill happen or anything else. You pour a little bit of that on it and it takes care of it. Now, for making nitric acid, it's like less than an hour's worth of videos you got to watch. These three people here are kind of the go-to ones. Nerd Rage has really good videos. I would put Blue Moonshine next. He's got a good website that also shows you kind of what's the formula that you need to use to make it. And then Nile Red. So watching those kinds of gives you a good feel of like, what am I going to need? What's the stuff involved? What's the process like? And so we'll talk a little bit about just the few things that you need. So you need a heat source, and ideally you want to be able to control the heat because you're trying to heat up this nitric acid that ends up being in this flask up to a little over 85 degrees Celsius. So it turns into a vapor and you're going to condense it down. You need a distillation setup. All this stuff is bought off of Amazon. So there's not special chemical suppliers or companies or anything else. So you have a boiling flask that you're going to heat it up in. That vapor is going to rise up through a little elbow tube over to a condenser. The condenser that you see with those little yellow tubes going into it is basically water cooled so that we're just cooling getting this vapor back down. And then the acid drips down into the little container and you go do your thing. And for the water cooling, this is the same thing. It's a cheapy little pump off of Amazon you would use for an aquarium or something else. It's just running water through the setup. Ideally, you have a scale of some kind. The process is actually super forgiving of mixing these two chemicals I'll tell you about, but it's nice to measure what you're mixing and then measure your yield and see did things actually go the way you thought they were going to go. Because some of the chemicals you buy, it's like the concentrations may be varied depending on how you're acquiring them. So it's helpful just to be able to do those measurements. And then the two kind of magic ingredients are stump remover, which is potassium nitrate, which you can get at any hardware store. You just got to make sure you look at anytime you want to buy something like this from the hardware store, you search for the MSDS, the Material Safety Data Sheet. It will tell you what's inside of this stuff that's being sold, and it'll just say 100% potassium nitrate. And you go, okay, good, that's the stuff I need. The other thing you need is sulfuric acid. When you mix those two, the result is nitric acid and some other stuff. You can get sulfuric acid also fairly easy. It's much easier to get than fuming nitric acid. The reason I'm making fuming nitric acid is it's not at the corner store. And it's also, if I tell them I'm a dude in my garage, not likely they're going to want to sell it to me. So I got to make up a whole story or whatever else to try to get the stuff. And then maybe they still don't sell it to me. Now for distillation, when you watch a lot of these videos, you basically heat it up, you add foil. The foil's incredibly important because you're heating up this mixture and you don't want to get it too hot because any water that is in the sulfuric acid, like if it's 90% concentrated or whatever, you don't want to heat that up into a vapor and kind of spoil the nitric acid you're making. And so you're kind of just, this is a bit of a waiting game here of how long you have to look at it. And then the acid will start coming out. And that's what you're capturing as part of that process. You can see when I'll come over here. So a lot of this is set up the way it is because I'm filming it, right? But if you look at the side of that boiling flask, you kind of see little drops condensing down. So anywhere where the foil is wrapped around, where you're not containing that heat, it wants to just condense and fall back down. So all you end up doing is either slowing down your process or you're tempted to crank up the heat, which is bad, right? So ideally you don't want to do that. But from having made it a number of times, it's like so forgiving. You can do all that stuff and you still end up with nitric acid that's good enough for decapping chips. Now, after I made it, then I started researching how do you store it. That's the wrong time to research how to store it. As I found out for weeks as I was not able to store it properly. And I Google and it says, make only what you need. Like, God, don't even store it. Don't think about it. These are like chemists on chemist forums. And so I'm like, oh, well, I'm screwed, And so the only thing I've found so far is what I call this dual container strategy. And so I have a ground glass jar, which I thought would be enough. It wasn't enough. It still leaks from it. I then put some of this PTFE grease around the top, which then you kind of rotate it a bit. That's a tip from Travis Goodspeed. Grease the top. I said, okay, I grease the top. I put it on. It's still managing to escape from there. So then I chatted with Nerd Rage and I said, how the hell do you store this stuff, man? And he said, well, I put it in another container with sodium bicarbonate on the bottom. And I basically just let that neutralize whatever fumes kind of escape. And so this second container is just one of these ones you see like you would store sugar or flour in or something that I got from the cabinet. It's just you can't use the rubber gasket that's on top. So I have a Viton gasket that I bought, which is also cheap on Amazon, like $20 for a sheet of the stuff. I just laid the rubber one on top there and I cut out, a shape that matched it. And then, put it on top of the lid. And I made a little round spot in the bottom to set the nitric acid on. So it's not just sitting in the kind of powder in the bottom there. And then the part you see on the top of the lid, those 3 little yellow strips are just pH test strips. And so that's if any vapors are making it pass, that's kind of the canary in the coal mine that'll tell me that something's changing. I had a test strip inside the second jar, but it just immediately changes color. So it's like you don't need to have one there. And so you see, I kind of just rotate that little thing there, get the grease to coat really well, set it inside. And this literally sits in a cabinet in my office, in my house, in the same room where I film reverse engineering news and everything else. Like it's that good at this point where nothing comes out and it's been in there for weeks. I take it out, I use it, I go outside. The other tip I would say right there is get yourself some cornstarch to put on your hands when you put those gloves on and off, because they just want to get hot and sweaty and then you don't get them on and off again after a little while. So once you have the nitric acid, then it's the process of how do we actually put it on something and get it to take the top of the chip off. So just a little bit more on safety. So, it's like we're literally boiling acid here. So you want to think about like, how are you doing this? How's your workspace set up, which I'll talk a little bit about. I think of it like a dance. So what you see me doing here is like nothing's open, right? The acid isn't open. That heat gun that I'm going to use to heat it up isn't on up there. I'm like, how is my workspace set up? Do I have to reach across things? Am I going to potentially knock something over as I'm doing it? And once I know the workspace is set up nice and I've got other things sitting around like my baking soda and everything's real easy. If an accident happens, I'm not trying to figure out how do I deal with it. Then I go on from there. And so kind of just think about what's your workspace set up? Is your fans in the proper location and all these things? Now, when you use it, you'll find out very quickly that regardless of where you put the acid just wants to go everywhere. And it wants to eat in all directions. And should it get a hold of some metal, depending on how concentrated your acid is, it'll start eating all of that up too. And so as I was doing this and I watched people online and everything else, what my thought was is there a better way? Is there a more focused way to do this? And there's not a lot of stuff that I found or pictures or videos or anything. So I kind of just started researching it a little bit. What initially got me to thinking about it is a couple years ago on eBay, I bought this thing called a jet etch. So if you're a failure analysis lab or something else, you probably have one of these. It's an industrial way of decapping chips. It takes the acid, it sucks it in. You put the little chip inside this machine upside down. It sprays hot boiling acid on it through a little gasket. This is a piece of that Viton gasket that I cut a little hole in. And it sprays that acid on the chip to decap. And I thought, this is amazing. I got this thing, I'm using it. And so I started chatting with McMaster a while ago and everything else. And he said, well, they're good for industry. But the problem is for stuff we do, we're doing 1 or 2 chips. And so you have to figure out all these settings and what do you have to put in and how long is it going to dwell and all this stuff. And he's like, it's just not so good for that. But the thing was, I looked at some of these, these etchings I was getting, and while there's some kind of issues with it in the middle, it's kind of dark to tell there, but the line around it is super clean, like how it cut it out. And so it kind of sent me on that path of could I come up with some other way to make a clean line like that? So the first thing I tried was the cheapest is just maybe if I just cover it with Kapton tape and cut a little area out in the middle, perhaps that's good enough, and that'll do it. And so I did some experiments with Kapton tape and putting some hot acid on to see what would happen, and it seemed to survive those tests pretty well. So then I taped it onto a chip. I cut out the little center area here. And so basically what happens is when you put the acid on it, it kind of wants to get underneath. And once it gets underneath, it starts eating away the adhesive. And so the challenge isn't so much that the Kapton tape dies, it's that the adhesive underneath it starts to die. But it still managed to control it a little bit in the center there and not have it go everywhere. So then I thought, well, I used a Viton gasket in that etching machine. So perhaps I can take a Viton gasket, I can get some of these cheap leather punches off of eBay, and I can just punch out the different shapes that I want to etch, put them on top of the chip, hold it down in some way, and get this kind of precise cutting out of it. And so I went down that path a little bit, and it turns out that spraying hot acid up is different from putting acid into the area and then heating it up. And so the cutout that you'll see, I made this little thing out of PVC here to like press down on my gasket right there. The cutout is shaped like an oval that's on that little chip right there, but the oval's kind of significantly bigger than the oval in the cutout. So I could make that cutout just a lot smaller to try to control it. But it just felt like, especially when I looked at that gasket right after I was done, it was kind of expanded out a little bit. And so there was some reaction going on with it in the acid. And so I decided, okay, I don't think this is going to work quite as well as I'd hoped. I've tried a few things with it, but it just doesn't seem to be quite as good as I would like it to be. But still, it is controlled more than the Kapton tape for sure. And so these are little PVC cups that are just from the hardware store. It turns out PVC is fairly resistant to fuming nitric acid. When you go online and search, you'll find everything that says it's not resistant at all, but that doesn't seem to be the case from all my kind of testing with it. So instead of using the big gasket, I thought, what if I could just use Viton O-rings? They're super cheap. You get them at the hardware store. I've got a box of them with me. It's like $10 for hundreds of them. And they come in all different shapes. And so if you don't own a lathe, you should own a lathe. So here's your excuse to go buy a lathe. This one's cheap. It's like a few $100 used. But what I'm doing here is I'm basically just making a hole and then an indentation in the middle there to put the O-ring in, but not have it be sandwiched all the way down, so that when I put it on top of something, it's got a little bit of squish room. You don't have to put a lot of pressure to hold it down, because the liquid that's in there isn't pressurized in any way. You just have to keep it from flowing out. So I'm finishing making this, and what I'm going to do is wire it onto a circuit board with just some enamel wire. So just wrapped around it. And this is a chip that's on a board, so I haven't pulled the chip from the board in any way. And you can kind of see it right there in the middle. There's just a little bit of a gap and it's not squished hard. I mean, you can only twist that enamel wire so hard before it just snaps. So it's just literally sitting on there in a way that I can rotate it. Because you'll see I got to put acid in it, and then I got to rotate it and pour it out and rinse it and all these things. And so once I had done this and I got this result, I said, okay, like this is literally as if I just drew a line around it and said, I want to remove this section. This chip is very thin, so it's fairly easy. But what you'll see is on the other chips, and a bunch that I brought with me, if you want to look at them at lunch and see what it looks like in person, those are all also very focused, and how it digs down. It almost looks like it digs straight down as it does it. Now, when I started this, I started like a number of months back. I basically took a large PVC pipe and I cut it up. I used a heat gun to flatten it and make a flat piece of PVC. I was going to use Teflon, and I went to a place and I sourced some Teflon, but I thought that's not very accessible. It's expensive. I'm not going to want to experiment with it very much, and I need to try a ton of different things. And so I just took, like literally I was in my garage just with fuming nitric acid just dripping on things. And I'm like, what doesn't burn up when it hits it? And I was like, oh, PVC doesn't burn up. That's, all right. So I'll just make this out of PVC. Which is why it was funny when I shared this online and I kind of shared the results. You'll see here, I took this thing, I wired that little plate down onto this circuit board here, and I was like, wow, that did a really good job of cutting just a perfect circle on that tiny chip. I tweeted it and everybody's like, oh, but it's too bad that won't work with nitric acid. What did you use? And I was like, no, I did use nitric acid. They're like, but it's PVC. And they're like, well, it's too bad it won't work with fuming nitric acid. And I said, well, I did use fuming nitric acid. And they're like, oh, and so then I went and searched the internet and found out, yeah, sure enough, if you look for PVC, it says it's not compatible at all with 70%. Forget about 100% and absolutely forget about boiling it. Like at that point, it's just going to turn to vapor. But it turns out it doesn't. It works perfectly fine. So I'm glad I didn't actually research any of that and I just dripped acid on stuff in the garage. Otherwise, maybe I would have never done it. So I wasn't super happy with the idea of wiring it down. So I took some brass I had left over from like a little clock making project. And I thought, well, what if I make a nice little holder for it, mill it out? I have a milling machine. If you don't have a milling machine, you could just cut it with a little saw or whatever. There's always a way to do it. I just have the tools. So why the hell not use the tools? And so I made this little shape here, and this shape allows me to make a bunch of different size PVC cups and hold them in this little holder, so then I can put any chip or circuit board between there, twist down those little wing nuts enough to hold it on there, and it gives me a nice little tool to hold, decap the chip, take a look at it real easy, and much more repeatable than like twisting wire around something. But like I say, there's always a way, like the wire way is possible, cutting that with a saw is possible, like, the tools shouldn't be something that limits you. And then I thought, well, what if I could do more than just a circle? And so I try to use FreeCAD for everything. I threw it in there and I said, well, maybe any shape that I could press an O-ring into, then I could cut that shape out of a chip. And so I started making rectangles and squares and all kinds of other stuff that I got with me. And that's the same. You can pop an O-ring into that. As long as you get your sizing correct of, what the diameter of the O-ring is, it presses in there. It works just fine. And I think it works a lot better. This is me actually using it, so doing my kind of dance setup that I got here that I rehearsed earlier. As long as the O-ring is kind of contained, all these reactions cause it to expand a bit. But, with the walls containing it and the directionality of where it can go containing it, it really just keeps the acid and focuses it down. You might only get one or two uses out of the O-ring, but that doesn't matter. They're cheap as heck. The cup itself seems to last quite a while. And you see all the hot, nasty fumes coming out of the top there. One interesting thing about using the little cup like that is you can actually really heat up the acid a lot and get a lot of use out of that acid to drill down into a chip. Because if you just put the acid on a chip without the little cup, the moment you heat it up too much, it just goes everywhere, right? And so you then really have to just be sitting there forever, like cooking this thing slowly, where with this, it's like it takes a minute and you're just boiling some acid, you dump it out, and there's the whole inside of the chip. Okay, so we're into the chip now. And we can see it. Let's take a picture of it and see what's there and upload it, post it on Instagram, all those good things. So there's kind of four major pieces you need. You need a microscope. It needs to be basically a top-down metallurgical microscope, so a little more expensive than your average one. You need some way to move the chip around, so depending on how kind of tightly you want to zoom in and image the chip, you need some stage that can move precisely. You need some software to basically coordinate that whole dance of getting the images and saving them and moving the stage. And then you need to ultimately stitch all those images together into one big thing like this that's in process, which turns out to be more of a pain than you would think. Sometimes you don't be surprised you get a lot of these when you're starting. And so I got a lot of those too. So like I said, on the microscope, you basically just need something like this little stage here. You see the light's coming from the top. Most of them, the light comes from the bottom of biological microscopes. So you just need some way to illuminate it from the top when you're doing this. This is an AmScope one. It was like about $900, something like that. But anything that can image from the top is good. You don't really care about the quality of the stage because we're going to rip that thing off anyways and put our own automated one underneath it. And this, these come off fairly easy. They seem to go back on about the same. I 3D printed this little piece, which is what my stage is going to sit on. But ultimately, that 3D printed part wasn't quite stable enough. Like as I started to try to image at higher and higher resolutions, I'd get all these little vibrations, like the air conditioning would turn on and all of a sudden I would see it on my screen over here. And it's like, that's not going to work for, when you're trying to take hundreds of images. So I had to make a piece out of aluminum. I more chose to make the piece because I have that stuff to do it. The other way I did it was just literally set the stage on top of the microscope, like on some piece of metal or something else, just so it was solid and not on a platform that can kind of wave around. So, same with this. You don't have to make this, but if you can make a nice bracket, then there you go. Now, there's a couple different ways you can go about with stages. This first way is probably the recommended way, honestly. Like it'd save you a lot of heartache, most likely. It would save me a hell of a lot of heartache. Because when I told McMaster the method I was going to do, he was like, no, you should just do this method. Like it would be a lot better. And so this is just a little CNC controller. It's an XY stage that you can get off of eBay. You put your kind of CNC motors on it. You print some little adapters to connect the motors to it, and then you can move X and Y. Then you take a Z-axis motor, you hook it up to your focus of your microscope so that you're moving the whole microscope up and down. You'd basically set this on top of like your existing microscope stage that you have, something like that. I have some kind of character flaw, so I chose the hard path. So this is the hard path. It's a Delta stage that's a 3D printed open source microscope, which sounds awesome. Delta stages are also awesome if you've played with them at all. So I printed this thing out real quick. I set it on the microscope. I start imaging underneath it, but the challenge is the software I'm going to use sends commands in a certain way to the stage. It uses a thing called Gerbil, which is like a CNC controller kind of thing, right? This stage doesn't accept it, but you can see it's like, this is not real time for sure. This isn't the magic of video that I've sped up here. But you're able to move that stage all around X, Y, Z. You could even level it with the 3 motors. But because it doesn't accept Gerbil, you have to provide your own motor controller and convert it. And so, this is just anybody that's not familiar. This is kind of how a Delta stage works. You're getting X, Y, Z movement on the top, but you're feeding in combinations of motor movements at the bottom. And so to get X, it's actually 2 motors moving together. To get Y, it's a combination of 3. And for Z, it's a combination of all 3 moving it up and down. And so, it's like, do I write my own? What do I do? And so I find, Fluid in C, which is it runs on an ESP32. It controls these things. My goal was to make this thing as dirt cheap as possible to do it so people can replicate it and actually make the stuff. Fluid in C actually supports kinematics, which is what you need to control all these motors. But the kinematic they had for a Delta stage didn't line up with how these guys did the OpenFlexure Delta stage. So I still had to end up writing my own. And so that's on my GitHub that you'll see at the end, if you want to do this along with some other stuff. And so those kinematics that are in there, basically, allow me to translate, accept Gerbil commands, turn it into the Delta stage. The other thing I added is when you have a Delta stage, there's no homing or anything in this. So the 3 motors can kind of be in any orientation when you start. And so ideally you could send some what I call ABC commands. So in CNC stuff, there's X, Y, Z to move the way you think. And then there's ABC, which are rotational for each axis. So I repurpose the rotational to control each motor individually. So then you can have a function in the software to level out your stage basically before you start moving it around, depending on what you put on there. I'd like to do some kind of automated leveling or something in the future, but there definitely wasn't enough time to get that done. And then you need a piece of software. This is Pi Microscope. If you know anything about stuff John McMaster does, this is what he uses. And this coordinates everything between your camera and your stage. All you do is basically pick the 3 corners so that it can figure out what's the orientation of the silicon you have underneath there. It will then go run, it will autofocus all those corners for you, and it will start a process of scanning. So we're seeing it autofocus the 3 corners here. This is with a 20x objective and an 18 megapixel camera, but cropped down a bit in the center. And so then now it's going to go, and I have it do focus stacking. And so focus stacking is just taking multiple pictures at every location. So it basically goes, it moves the Z-axis down, it takes 7 different pictures or however many pictures you want it to, and it goes to the next location. The nice thing about this focus stacking that he has in there is that it lets you set basically a drift compensation. So every time it does a stack, it says, was the middle of the stack where I assume the middle would be the best focus? And if it's not, then it adjusts that on the next move. And because of the fact that I'm using a 3D printed stage and there's just slop and all kinds of things, gears and everything else, this helps to compensate for that. So what is slop? Slop is like the fact that I'm moving these little gears here with my fingers and they're moving, and ideally they wouldn't move like that and everything would just be tight, but there's always some kind of slop in a mechanical system you have to overcome. Ideally, I'll overcome this as an update to the motor driver software, and it'll be in there programmed how to deal with the backlash, but because I didn't have time to do that, I just literally compensate with software. This is just a little animation to show you the focus stacking. If you have 13 images, it's taking the sharpest part of each image, it's then compiling that together and making one awesome image out of it. Now the result from all that, so the scan I did was 13 Z stacks on each location, 27 by 25 tiles. So ultimately it takes a little over 8,000 pictures. It focus stacks that down to 675 pictures. You can't load all of that into ImageJ, which is a software I'm using at one time. It'll just sit there and tell you that it's making progress, but it doesn't make any damn progress. Like, it just sits there for, as long as you want to leave it sitting there. It crashes in some weird way because of the size of the image. So what I do is I take 15 by 15 blocks, which seem to be about the largest you can feed into it. I feed in 4 squares like this. I then take those 4 squares, I feed those back in, and then it stitches those no problem. So I thought it was an image size limit, but obviously these 4 are the same as the one big one. But I don't know what's going on there. But it's free software, so what the hell are you going to do, But then ultimately you get this, which is imaged with the 20 times objective. Lets you zoom in, look for anything you want to look for ROMs, all that kind of stuff. That's the result of it. That brings us to today. All right. So thank you. I'd also just like to thank, obviously, everybody at this conference for putting this together and everybody for giving their talks. They're all super awesome. And the number of people that helped me, obviously, Travis and Nerd Rage and McMaster, a ton of people or how this actually got put together. I just kind of slogged and did all the work to put it together.
All right. That was an awesome talk. Thank you so much.
Yeah.
Anybody have questions?
This might be a really dumb question, but it seems like there's a lot of people making fuming nitric acid. Is it just for decapping, or are there other uses that you can do something interesting with?
So the people that are on YouTube that are making it, I think most of them do it because it's dangerous, and when you spray it on stuff, it explodes into flames, and that makes for a good YouTube video. Other than decapping, I'm not sure, honestly, what you would use it for. Oh, yeah. So you don't need fuming nitric acid for gold. Like, you can use a 68% or whatever, but yeah, a lot of people that do gold recovery and stuff, for sure, that's a good one. I've seen forums where they're like on an industrial scale of the stuff they're making, and how do I deal with it, because they're trying to recover a lot of, yeah. I also brought all the little kind of cups with me, all that stuff you saw when I'm sitting at lunch out here. If you want to take a look at kind of what those things look like, what the various stages of the chips look like, when they were being decapped, you can check it out over there.
Any other questions? Yeah.
Since I saw you were decapping chips like in circuit, did you try to operate any of those after decapping them? And what other kinds of effects did you see that nitric acid had on the actual layers on the silicon?
Yeah, so that's a good question. So the whole point of why I was doing it with fuming nitric acid is ideally, I want the chips to work when I'm done. I want to actually run them in circuit, and I want to be able to do things like you'll see in some of these workshops where they're actually probing the chips while they're running. When I went and visited John McMaster, he did some of that where we decapped a chip. We actually probed it live while it was running, pulled data off a line using this whole probe station setup that he's got going on. So these I haven't, and also I should say, depending on what chip you decap, there's all these different kinds of processes and technologies. So if they have gold bond wires or whatever, it's much more forgiving than if they have copper or something else, which just vaporize like almost immediately. So, finding some older chips you can work on, or depending on what the chip is, help when you're doing this. But that would be my goal. Like probably stuff you'll see me do next will be like, okay, can I decap some EEPROM and actually read it out while it's going? I've seen it work in person because when I was at John's house, we decapped a PIC chip. We powered the thing right up in a programmer. It runs just fine. We painted nail polish on top of it to actually cover up the fuses and then expose it with, cover up the ROM, but then expose the whole thing with UV light that erases the fuses. So there's a lot of interesting things you can do, and literally just, using hand tools and stuff like that is what we were using, not specialized stuff.
Questions? More questions? Anyone?
Yeah, but some processes you'll do on it, like one chip to clean off some stuff that was on the top. I put a tiny bit of sulfuric acid because the nitric wasn't doing anything. And then it just vaporizes like the metal immediately. And see, okay, well, that's not working anymore. Like it gets a nice picture, but it's not going to actually turn on,
All right. Thank you so much.
Yeah.
Everybody, give Hashem another round of applause. Thank you.